Hi, this is Adam with DataNab.com, and today I'm going to be giving you a quick look at our new Modbus I/O12 LCD device. This is a programmable I/O device, and when we at DataNab say programmable I/O device, we typically mean it's programmable using our Modbus I/O flash software. It's also a Modbus enabled device, which means it can communicate on RS-485 networks using the Modbus RTU protocol. So you can see the device here. It's a wall mount or a true surface mount device. It can be mounted on the side of control panels, it can be mounted on an electrical box, or it can be mounted on the wall. I'll show you a close-up version of one in my hand here. It's got a nice LCD screen at the top. It's got buttons to interface with the user here. On the back it's got you can see the back plate that goes on the wall. I'll pull it off here. This back plate is meant to mount on a surface, a wall or a control panel or electrical box, and then the wires come in through this hole in the back and they connect up to these terminals here. You can see the I/O points. We have our analog inputs. We prefer to call them universal inputs on the left because they not only can read analog signals, but they can read digital signals and contact closures as well. We have our relay outputs on the right side, and then we have our analog outputs below the relays here on the right side. So that's how the wires are hooked up and how the terminals work. This goes on your surface, this hooks to the top, slides right down over it, and now you've got a device, a true surface mount device that's easy to connect, easy to access the connections off the back and things like that. It just hinges right out. If you look at the inside of the device here, the terminals are also labeled. So you can see it's just reversed, since when this backplate goes on here it flips over, but you can see your universal inputs over here, your relay outputs here, and your analog outputs here. While I'm showing you this view, it's worthwhile to note the input jumpers here. You can define how you want those inputs to work. The diagram for the input jumpers is there, so if you want to configure one of these universal inputs to read 0 to 10 volt signals DC, you use the diagram shown on the left there with the jumper in the top two positions. You can see the 0 to 20 milliamp position, the thermistor position, and then the 0 to 5 volt DC position. The dry contact position would be the same as the thermistor, so the jumper and the two bottom pins, which is what it comes, that's how it comes configured by default. It may be difficult to see here, but there's also 4 jumpers here just to the left of these relay components. These jumpers are for the analog outputs. One of the nice things and unique things about this device compared to some of our other devices is that you can configure those analog outputs to be 0 to 10 volt outputs or 4 to 20 milliamp outputs with these jumpers. So they can be used for current loop outputs and things like that as well. Another thing to notice here, looking at the device, bottom of the device we have a nice little push button, a little black push button. You can probably hear it clicking. And that button can be used to turn it into an occupied mode, or however you want to use it in your program with Modbus I/O Flash. So you can wire the input of this in your program to trigger anything that you want. It might trigger some demand mode or occupied mode, or it might trigger an alarm or anything like that. It might trigger it to go change the set point to an occupied set point for a certain amount of time. However you want to use this button, it's wide open in the programming software, the Modbus I/O Flash software. So that's a nice new feature on this Modbus I/O12 LCD device. Another nice feature is, you can't see it here, but in the top there's a little light sensor inside this slit here, this slot in the packaging or in the enclosure, and that allows you to sense ambient light levels around the device, which might be nice if you're doing lighting control or something with a dimmable ballast or something along those lines. So those are the hardware features of this device, or the way that it looks out of the box. One other thing to note about this device is that the universal inputs, the 8 universal inputs, are actually 12-bit inputs. And now that's new and different from our other devices. Most all of the other programmable I/O devices that we have that can be programmed with Modbus I/O Flash all have 10-bit analog inputs. This device actually has 12-bit analog inputs. And as I showed you before, another big difference is the 4 analog outputs versus 2 on some of the other devices is a nice upgrade. And being able to switch those analog outputs from voltage to milliamp mode is also a nice upgrade. So now I'll get into what this device looks like when you actually power it up. As you can see here, I've got wires going into the back of it already. This is just a wiring harness, which we'll use in a little bit to be able to measure the voltage on some of the points and what's happening electrically on some of the points. Coming out of the back of this, I have a couple temperature sensors that I've got wired into universal inputs number 1 and 2. And then I've got this wire. This is a 4-wire cable. 2 of the wires are for the RS-485 network, which are connecting to our little Modbus gateway here, and 2 of the wires are for the power. This gateway is our Net 485 device. I'll show you a close-up of it here. We actually buy this device from Grid Connect. It's called the Net 485, and it is an IP to 485 converter. So basically you've got your Ethernet plug on one side, and then you've got your power and your RS-485 lines on the other side. And what this enables us to do is we can plug an Ethernet cord, as shown here, into one side of it, and have RS-485 going out the other side of it into the back of one or more than one of our devices. And then from my computer here, which is operating on Wi-Fi, I can actually communicate to this device, even though it's a Modbus device that's designed to work over RS-485. This little box converts from Ethernet to 485 for me, so now I can talk to these devices anywhere in the world over the internet, because I'm using this Ethernet to 485 gateway. We also have other options to communicate from your computer to our devices with MBus I Flash. This is a USB to 485 converter, so you've got your USB here on this side, and your RS-485 lines come out this side. Nice thing about this is it's powered by USB, so you just plug it into the computer, and 2 wires out of this into the back of your device, and you're talking. Both of these methods, the IP to 485 and the USB to 485 converters, are available on our website. You can purchase both of those devices on our website, and they allow you to talk from a computer using Modbus to one of our devices. And if you're going to use MBus I Flash to program these devices, you're going to need a way to get from the computer to the device, and that'll be either the IP to 485 converter or the USB to 485 converter. So when you get this device and you get it powered up and you've got it connected to your computer using a converter, a 485 converter like this one, when you get it from us, we have a default program loaded on it. We call it our default template for the MBus I 12 LCD, and what that template basically is for is so that when you turn this thing on the first time, it's doing something. So in this case, the default templates enables you to see the I/O points, and if you want to see the other I/O points, you just push the arrow buttons to scroll through them. So this is showing the built-in temperature sensor of the device. As I mentioned before, we also have 2 external temperature sensors coming out the back, but in this case this is the built-in temperature sensor feedback. If I scroll to the right, this is the push button showing the status of the push button, and so you can easily push this button here and see if it's active or inactive. So when I push it, it goes active. When I let go, it's inactive. So that's just a quick demo of how you can use this push button, and it's showing that this device indeed is detecting the change. And MBus I Flash, in our default template program, we have told it to include that object and show the status of that object on the screen. That's one of the very powerful things of MBus I Flash is, we can tell it what this line should say, and we could tell it what this line should say. So we could have this easily saying, instead of push button, it could say bottom switch or switch. There's a limit of 8 characters, and we could say on or off here too, or we could say yellow or red. We could tell it to show this status however we want to show it. So that's a push button. If we continue to scroll, this is showing our light sensor, our light level sensor that I mentioned before. So if I cover up that sensor on top, you can see the light level goes down. And if I open up and allow the light in, it goes back up. So that's going to be a level between 0 and 100. And you can use that to control lighting circuits or dimmable ballasts or anything else that you might want to do based on light levels. As we continue to scroll here, there's our first external temperature sensor that's connected to universal input number 1. So what I'm going to do is put my finger on the sensor here, and we'll see it must have been on the other one, so I'm going to switch over here. Sorry, I got a reflection in the back. So you can see as I put my fingers on this sensor, It's starting to heat up, and the response is fast. Obviously my hands are pretty cold. The input's very fast. You can add filters to it, but this is a fast, accurate device, and so you're gonna have a fast response. So that's the first one. If I go to the second one here, I can do the same thing to the second temperature sensor, and you can see how it's changing in response to the heat of my hand. Okay, that's universal input 2. Now the rest of the inputs, we don't have anything connected, so it's just showing the raw 12-bit value that the input's reading right now. So we get through the inputs here, and again, the reason you're seeing this stuff is because that's how we have the default template programmed. We have it programmed so that you can see the status of all the I/O points, and we can control the status of the relays and the analog outputs. So now the inputs are read-only points. These outputs, we made them writable. So now I can use the up arrow and the down arrow to turn the relay on and off. Okay, and to actually see how those relays work, that's why I have this meter here. I'll pop on this meter quickly, and I'm going to put it in continuity mode, and you can see through this meter the feedback that the relay is actually working. So there's I think that I'm on the right 2 points here. I'll pop it on and off. Okay, so you can see that relay is working. And so it's kind of nice, you get this out of the box. You have a real simple way to test out the points right off the bat without even adding a program. Next thing you'll see is the 4 analog outputs. So I'm going to do the same thing here, except I'll put this meter on DC voltage mode, and we can measure now with this meter. We can measure analog output 1. That's why I have this wiring harness here. So as I go up 0.1 volts, you can see the meter go along with me. So these are very accurate analog outputs. They're very powerful as far as they're 0 to 10 volts or 0 to 5 volts or 4 to 20 milliamps. And you can see how accurate it is. I'm showing 5.6 volts here, and my meter's reading 5.61. And so you can see the response time is very fast by watching the meter here. And you can see that it's accurate as well. So this is a pretty big step up from our previous devices as far as the speed and the accuracy. This is a very high-end device, and it can be used to automate almost anything with the high number of I/O points that are available, and then the accuracy not only on the analog outputs but the 12-bit analog inputs as well. So once you get through the analog outputs, you basically roll over and go back to the beginning. So that default template that's loaded on this device when it arrives can be downloaded from our website. I'll put a link up here on the page right now, or on the video right now. Once you've downloaded that template, you can open it up in MBus IO Flash, and then you can use MBus IO Flash to take a look at the program. That's what I've got running right here on this laptop right now. Now I'll go into run mode. It's probably very difficult for you to see this. Okay, let's see if we can figure this out here. Try to scan it in. It looks like I'm having a slight issue here. Oh, one thing I forgot to mention is, this is a good chance to bring this up. This device, when you get it out of the box like this and turn it on, it's going to be in user mode. Additional parameters can be set up and configured to show up on this display, but only if you're in admin mode. And to get into admin mode, you push and hold these outside buttons. It'll say user and continue to hold until it says admin, then you can let go. And now what happens when I scroll through is I'll see a couple additional parameters, anything that was defined to only show up in admin mode. And one of those parameters in this case is the address. So the address is set to 253. I can change that address now with the buttons. So out of the box, if I've got a Modbus master and I want to try to talk to this device and get the values of the inputs and be able to control the outputs over Modbus, I can do that without even putting a program on it. I can set the address here and I can talk to it over Modbus. So I am going to go ahead and close out this software here, and this isn't really necessary, but I wanted to show you just real quick how simple it is to connect with the MBus IO Flash software. There we go, back up. I had let it hibernate and then it closed the connection on me. So basically this is our MBus IO Flash software. Again, probably almost impossible for you to see it on the video, but I can get in here through this software, and if I was a user and had just downloaded this template and loaded it up here, I could use this as a starting point for my own program because all the outputs and inputs are in there. I could go into a hardware configuration section and click up here on where this LCD display is, and this is where I define what's going to show up on the screen, and by having this default template already here and seeing how it works, I'll be able to figure out how it's done. You can also look at our MBus IO Flash video for more instruction on that. And then I can also go into run mode here, and you see these little tags that popped up. It enables me to control the relay outputs. So if you listen, I can click here and I'm turning the relay on and off, the same as if I was doing it with the buttons. So I can actually scroll through to relay output 1 here, and you can see how I'm controlling it now from my software here rather than with the buttons. I can do it both ways, and then it shows up in the software as having changed as well. So it's kind of nice to tie it all together using this software. I can also see the values of all the inputs through here and things like that. So yeah, I guess that's all I wanted to go through for the MBus IO12 LCD. If you have any questions, make sure you shoot us an email. You can find our contact information on our website, datanab.com. That's DATANAB.com. I also have the information in the description part of this video. And as you've seen, there's been some notes that have popped up over the video from time to time containing some additional information that might be helpful to you. So if you have any questions, shoot us an email, and we'll be happy to help you out. Until then, don't hesitate if you want to try out the software, the MBus IO Flash software, which is right here. Get on the website and download it, and you can try it out in simulation mode. Again, there's more information on how to use that software in another video. And then once you get comfortable with the software, go ahead and order a device off the website, and then you'll be well on your way to automating something or monitoring something or controlling something, whatever you want to do. These are very flexible and powerful devices. So hopefully this helped you out, and we'll talk to you soon. Thanks.